Hi friends, this is a lecture on vector analysis unit 1 ph 1501 by Dr. M.R. Gadhvi. In the previous lectures we have seen about a gradient. With the same unit we will be learning another two property for the vector. One is a divergence and another is the curl. CURL curl. So let us understand what is exactly happening, what is the difference between the normal dot product and cross product context 2, divergence and curl and gradient. So suppose you have a vector A and that vector A is multiplying with a one scalar quantity, so it would be written as A into small a. Now you have a vector A and you have a vector B and you want to make a dot product, then you can write A dot B. If you want to take a cross product, you can write A cross B. This is everything you had learned in your 12th grade. So now what we have seen in the last lecture and how further it would be useful, that we will see in this lecture. So we have learned a del operator in the last lecture. Del operator is given by, it is written and shown by a delta notation of a Greek Latin alphabet, and it is a vectorial operator. So it is something like a partial derivative of all the three coordinate with the unit vector. So it would be written as del, that means, so in word it would be written as a del, del. So that del will be written as the partial derivative of x, y and z components and their unit vectors. So suppose this del operator is applying on a function t, and if the t is a scalar function, then that is known as a gradient, and it would be uttered or it would be said as gradient of a function t. If the del operator is applied as a dot product, with reference to the vector v, then it would be written as a del dot v. There is a one more option with the multiplication with a vector. So a del operator with a cross product, okay, and that would be del cross v. So you have a vector v, but the application of a del operator in a two-way other than the gradient is either it would be a dot product and or it would be a cross product. If del operator is applying on any particular vector in dot product, then it is known as divergence. And if del operator is applying on any vector with a cross product, then it is known as curl. Okay, the divergence can be understood in the following manner as shown in the slide. So del operator is nothing but which is shown over here in the bracket. That means del by del x cap, del by del y cap plus del by del z cap. This bracket is nothing but the del operator. It is making a dot product with a vector v, and v having a three component in along the x direction, along the y direction, along the z direction. This vx x cap plus vy y cap plus vz z cap is making a dot product with this. So if it's an orthogonal vector, that means if x is making a dot product with y and z, it would be diminish off if since it is a orthogonal to each other. And identical vectors, that means along the same line, x cap dot x cap is equal to a unit, and therefore eventually this dot product will give me a scalar outcome. So divergence, that means a vectorial del operator is applying on a vector, and the dot product as an outcome you are getting a scalar quantity. And what exactly the interpretation of a divergence? So it is nothing but the measure, it is a measure of how the vector v is spreading out. कोई एक वेक्टर है तो वो spread out कितना हो रहा है. Let us say a point charge in a space is shown by a vector. So at that particular position, how that vector is spreading out or spreading in. Suppose it is a divergence is outcome is a positive, then it is referred as at that particular point of interest the divergence is positive. That means there is a flux is spreading out, or the flux density is positive. That means flux per unit volume is positive. Whereas there is also possibility that there is a flux is going in, so that would be referred as a negative divergence, and that is nothing but the convergence. So if del dot v is positive, that means it is a diversifying vector, diverging vector, and if it is a del dot v's result is negative, that means it is a converging vector at that particular point of interest. Okay, so if I take a one pictorial representation, it would be much easier to understand. So if you look at the figure 18a, then the dot is radiating the radiation in all the direction, maybe the field also, you can term that like that. And look at the size of arrow, then arrow is increasing, right? And therefore you can say that the spreading is healthy, it is flowing out. Suppose सोच लो कि यही arrow कम वाला है, that means this the bigger arrow is inside the circle but pointing in, and smaller arrow is the outer circle and pointing in. Then you can say that from smaller arrow to larger arrow as they are coming towards the center, and therefore it is known as a converging function, or you can say that it is the flux density will be negative. If you look at to the figure B, then all the size dimensions are identical and equidistant. This is also saying that the vectors are identical, that means it's not diversifying, it's not divergence or convergence, and therefore d or the diversion of this particular vector as per this figure B, it is 0. Let's go to the last one. They looks like a straight lines, right? There is a one student to ask me that sir this is going straight. यहाँ पे तो समझ में आ रहा है कि ये डाइवर्ज हो रहा है, लेकिन यहाँ पे तो डाइवर्ज है ऐसा दिख ही नहीं रहा है. तो आपको एरो के मैग्नीट्यूड्स पे जाना है. Smaller to larger, as it moves in this direction, the arrow's sizes decrease, that means flux is increasing. So flux volume per volume or the flux density is enhancing. That means this is also having a positive divergence. Let's take an example. So what exactly we are doing, as we have seen in the previous slide, that divergence will be written as a del dot v and it is nothing but, in principle, as per equation 40, it is a partial derivative of the given function. So we will be doing same in this case, and try to understand the example number 4. Suppose we having a function which is representing that figure a, b and c of 18th number. Va, this is a Vb and this is a Vc. Va का डाइवर्जेंस निकालना हो तो del dot Va and therefore partial derivative with x, तो यहाँ पे x कंपोनेंट है तो इसका मैंने partial derivative ले लिया. So x cap का component, that is a vector component, is x. So del by del x of x cap dot x cap, or x cap के dot product, that is equal to 1. So if you are not going to write it out, that is fine. X cap is multiplying with the y cap and z cap, it gives vanish off, so I am not mentioning here. Similarly, del y by del y, del z by del z, and therefore it's a 1 1 1. Since there is an addition of the sign, so it becomes a 3. In nutshell, the divergence of a vector Va is positive, that is number 1, and the second one is, we can conclude that it is a diverging, it is diverge out from that particular point. So it is anticipated that this function having the positive divergence. If you look at to the figure B, all equal magnitude size of a vector, and it's shown in a straight manner, and therefore if I will take it Vb, there is no x, there is no y, so del x and del y automatically become 0. Think about the z cap, so there is a nothing component, no component, so it's by default 1. So del by del z of 1, and 1 is a constant, and constant's derivative will be 0, so z is also 0. So nutshell, we will be having the 0, and this is also true in the case of last, that is a Vc. In Vc, if you look at, there is a only one component is available, that is Vc z of z cap, and if you take a derivative of that, so naturally x and y are missing, so there is a 0. So naturally the product of first step and second step will be vanish off, so that is 0. And over here I can write del z, del by del z of z, so that is equal to 1, so positive 1. So again Vc vector is also positive divergence. So this way you can also try to solve the example number 15. Very simple, 3 example, try to submit it, and similarly you can think for to find it out or divergence of a given any vector. Let us assume that there is a vector, assume that between a 2 point x and xyz, and x dash, y dash, and z dash, so beginning point and the ending point, and that way you can take it up the r position vector, divide by r square, and try to rectify it. For your hint, I have already mentioned that answer is 0. Okay, let's go to the next new property, that is a del operator is making a cross product with a vector, then it is known as a curl. Curl is basically gives us the information that how the vector is whirling on or making a cyclic or circling across up one point like a tornado. So that information can be retrieved by the curl function. And if you look at here, del operator, that is a x cap, y cap, z cap in a first line of a determinant. Second line become a del by del x, del by del y, and del by del z. So it becomes, that means you are taking a partial derivation, and on which vector you are making a cross product, so that is a v. So that would be the third line. Okay, and in general the middle column is with a negative sign, but I interchange this two step, the bracket situation, and therefore it become the negative become a positive. So it is a del vz by del y minus del y by del z, and that is known as, that is with the direction with the x cap. And similarly for the y cap and the z cap, 40 number equation, equation number 41 will represent the curl. I think if I will go what it mean by curl very fast, then as I told, it will gives us the information about the how it is whirling about a one point or swirl around a point, and that is the more important. If you look at, all the arrows are whirling and making a cyclic rotation, just like a wind, a tornado or a water tornado, and where it is towards one particular vertical axis. Our vertical axis over here is a z, and therefore it is whirling around, swirling around that particular point. अगर उसकी साइड में अगर बी फिगर अगर आप चेक करो तो वहाँ पे एरो की फ्लो इज डिफरेंट, राइट, एंड as you move away your flow is also changing. So whatever it is coming, the same amount of the flux is going back, and therefore the flux density at this particular point comes out or thinks to be 0. Anyway, thus the function in figure 18 all have a 0 curl. Okay, as you can see easily, check for yourself whether the functions in 19 have a substantial curl which is pointing in a z direction. So the direction, if you take it, the del is crossing with the v, so that would be in the z direction, can be interpreted by using the right hand thumb rule. And yes, so imagine that you are standing at the edge of a pond and float some pedal boards, then naturally each pedal will producing the disturbance in the pond and the ripple will be developed. If it starts to rotate, then you place it at a point of a non-zero curl. The whirling or a whirlpool would be region of a large curl. And curl could be measured by this way. So suppose you want to measure of a VA, so that is a del operating, making a cross product with a VA. So how to write it out? In a determinant x cap, y cap, z cap in a first row, second row the operator tool that is on x axis, y axis and z axis, and this particular is a vector v function, that is x cap with the minus y and y cap with the x, and z is 0, and if you solve out it becomes the 2z. Similarly, vector b is applying with the del vector, and it comes out to be only z. So as it is expected, curl point is in the plus z directions. There are some summary kind of things, and how exactly product is applying on a scalar, on a constant, on both the scalar quantity, and that is understand over here very briefly. Let us say d by dx and f and g both are the scalar functions, and summation of both scalar functions, how the derivative will be implemented on it. So it becomes a d by dx of f, d by dx of g. And रूल ऑफ मल्टीप्लाइंग बाय अ कांस्टेंट, मान लो कि आपके फंक्शन को कोई कांस्टेंट से मल्टीप्लाई कर रहे हो, दैट इज अ के, so k will remain as a constant multiplier even of your derivative, so df by dx. And thereafter the product rule. So in product rule, suppose your both the functions are in the multiplying to each other, then the solution of d by dx of f and g, it will be like f of dg by dx plus g of df by dx. The quotient rule, that means f by g, the ratio of f by g, and can be solved by g of df by dx minus f of dg by dx by g square. Now this is a normal derivatives. Now let us introduce the del vector, and if del vector is exactly applying over here, instead of a d by dx single line derivatives, let us say del is applying over here, then how it is, I can write it out, it's del f plus del u. So gradient of f and gradient of g, and that would be in the also sum operator with the sum. Same way del, now with the del dot we are applying on the two vectors. Remember that it should not be a non-vectorial, so del dot a plus b, so it become a del dot a plus del dot b. And same way it's in the cross product, that is a plus b is making a cross product with the del, so it's a del cross a plus del cross b. In addition to that, if del having a multiplication, so kf, so k will stay outside and the gradient of f could be read out. And same way in a dot, k will remain outside and del dot a, and finally del cross ka, where k will comes out and del cross a could be written. So in short, this is some summary in brief. In continuation of the same summary, we can having a f into a cross b, so this is the upper one is a scalar times of vector, and a cross b, that is a cross product among the two vectors. We do have some 6 rules are there for the gradient and divergence. Let's try to understand. So gradient of f and g together, it could be written as f del g plus g del f. And the second way of writing out the del operator, that is in the dot product. So a dot b, if both are vectors, so the result having a dot product having the scalar. If it's a scalar, then definitely a del program could be run over there, and therefore it would be written as the entire RHS part. Okay, so del f of g is written as f del g plus g of del f. The third one is over here, and that is a del dot f of a. Now f is a scalar and a is a vector. So when I will say it's a f outside, that means scalar is outside, so it become a del dot a, plus when a is outside become a del f. So that's the gradient, the second bracket, and the first bracket is the scalar. The fourth rule is del dot a cross b, so it would be written with this particular. So even in exam I can write it out as a one of the best option. So try to remember this, all are the expansion of the LHS guideline. Anyway, the last page of my lecture is summarized with the another 2 rules and few fundamentals. So the del cross f of a is written as f of del cross a minus a cross gradient of a. So that is something like this, and a del cross a cross b, and again there is a del cross f of a. So एक स्केलर है, एक वेक्टर है, उसके साथ क्रॉस प्रोडक्ट ले रहे हो, so it become a basically a curl, but still f of del cross a minus a cross del f, that would be the one understanding. clause number 5, and clause number 6 is like this. It's a very long one. Okay, so you try to remember the RHS part, or I can put it RHS part and you have to find it out the LHS part. Okay, so if it's a offline exam, then this all are the need to be understand very clearly. Take a pen and pencil and try to solve it, but otherwise it is just numerical numbers. Okay, del dot fa is something like how I can prove it. So del by del x f a x plus del by del y f of a y plus del by del z f of a z. And therefore, if it is so, so this is a one scalar and one vector. So it would be written like this. So del f by del x ax plus f into del ax by del x. And if you look at all the three brackets for the further development of f of ay and f of az, then ultimately you may have over here del f dot a plus f of del dot a, and that way you can having the clarity of the del dot f of a. The another way of applying the gradient rule, that is on a quotient rule, and that is a del of f upon g. You may having a del dot a by g, that is a is a vector, and third way of possibility is del cross a by g, where a is the vector and g is the scalar. So it is the same way you can develop as you are developing here. Thank you so much for paying attention. Stay home, stay safe. Good luck.